Hena Shah, Assistant Professor at LJ Institutes of Engineering and Technology. So today we are going to solve few more examples of a topic, namely chain rule from partial derivatives. So let us begin with the first example. So if r square is equal to x square plus y square plus z square and v is equal to r raised to m, then we have to prove that del square v upon del x square plus del square v upon del y square plus del square v upon del z square is equal to m into m plus 1 into r raised to m minus 2. Or the question can be asked as, if r square is equal to x square plus y square plus z square and v is equal to r raised to m, then there will be a minor change in the question, that is del by del x, del by del y and del by del z will be replaced by this del. In short, it will be given by del square v, that is equal to m into m plus 1 into r raised to m minus 2. So now let us begin with its solution. So here we are given r square is equal to x square plus y square plus z square. So firstly we will do the derivative of this r with respect to x, keeping what constant? Y and z as constant. So keeping y and z constant, the derivative will be 2r del r by del x is equal to 2x. So finally del r by del x will be equal to x by r. These 2 and 2 will get cancelled. Similarly del r by del y, which is equal to y by r, and del r by del z will be equal to z by r. So now let us find the value of del v by del x. Here we are given v is equal to r raised to m and r square is equal to x square plus y square plus z square, right? So v is a function of r and r is a function of x, y and z. Because v is a function of one variable, so here we will put v, and here r is a function of more than one variable, so we will put del. So finally the formula of del v by del x will be equal to dv by dr into del r by del x. So now let us find the values of the derivatives. So dv by dr will be equal to m into r raised to m minus 1. And this value we have already found out, which is x by r. So on further simplification we will get del v by del x is equal to m into x, and this term will become r raised to m minus 2. Similarly, we can find del v by del y. It will be equal to m into y r raised to m minus 2. Just replace x by y and then replace x by z. So del v by del z will be equal to mz r raised to m minus 2. Now let us find del square v upon del x square, that is equal to del by del x into del v by del x. Just put the value of del v by del x, which is equal to m into x into r raised to m minus 2. Now we have to find the partial derivative with respect to x, right? So here we will put m as constant and outside and apply uv rule. But we know what is our r? R square is equal to x square plus y square plus z square. So in this put y and z as constant, right? And apply uv rule. So x will remain as it is and derivative of this will be m minus 2 into r raised to m minus 3 del r by del x plus, keep this as it is, r raised to m minus 2 as it is. So derivative of this term will be equal to 1. Now we have the value of del r by del x, keeping y and z constant, that is x by r. So on further simplification you will get m into r raised to m minus 2, we have taken this common, and into x into x, that is x square m minus 2 upon r square plus 1, right? Similarly, we can find del square v upon del y square by just replacing x by y, right? So del square v upon del y square will be equal to m into r raised to m minus 2 into y square m minus 2 upon r square plus 1. Similarly, we can find del square v upon del z square by replacing x by z. So, we will get m into r raised to m minus 2 z square m minus 2 upon r square plus 1. Now, what we will do? We will add 1, 2 and 3. So, on adding 1, 2 and 3, we will get del square v upon del x square plus del square v upon del y square plus del square v upon del z square, that will be equal to m into r raised to m minus 2 into x square plus y square plus z square into m minus 2 upon r square and 3 times 1. So, it will give us 3. Now, we know that x square plus y square plus z square is r square. So, this r square and r square will get cancelled out. And what will remain? M minus 2 plus 3. So, that will give us m plus 1. So, finally, our answer is del square v upon del x square plus del square v upon del y square plus del square v upon del z square will be equal to m into m plus 1 into r raised to m minus 2. So, this is our desired answer, right? Or we can write in this form. Now, let us go to our next example, which is given as if r square is equal to x square plus y square plus z square and u is equal to f of r, then we have to prove that del square u upon del x square plus del square u upon del y square plus del square u upon del z square is equal to f double dash of r plus 2 by r f dash of r. Or our question can be asked as if r square is equal to x square plus y square plus z square and v is a function of r, then prove that del square v is equal to f double dash of r plus 2 by r f dash of r. So now let's move on to its solution. So here also we are given r square is equal to x square plus y square plus z square. So find the derivative of this term with respect to x. So what we will get? 2r del r by del x is equal to 2x. This 2 will get cancelled out. So finally del r by del x will be equal to x upon r. Similarly, we can find del r by del y by just simply replacing x by y. So answer will be y by r. Now replace by z. So del r by del z will be equal to z by r. Now let us find del u by del x. Now we know u is a function of r. U is a function of r and r square is equal to x square plus y square plus z square. Right? So u is a function of r and r is a function of x, y and z. Here we have one variable, so we will put d, and here we have more than one variable, so we will put del. So the formula will be del u by del x is equal to du by dr into del r by del x. Now du by dr will be equal to from this f dash of r, and already we have the answer of this as x upon r. So final answer of del u by del x will be equal to x into f dash of r upon r. Similarly, we can find del u by del y. Just replace x by y. So answer will be y into f dash of r upon r. And lastly, replace x by z. So answer of del u by del z will be equal to z into f dash of r upon r. Now let us find del square u upon del x square will be equal to del by del x of del u by del x. Now replace the answer of del u by del x, that is x into f dash of r upon r. Now we will apply two types of rule, that is derivative rule of u dot v and also of u by v. Right? So firstly we will consider f dash of r as our u and whole x upon r as v. Understood? So keep f dash of r as constant and do the derivative of x upon r applying our u upon vu. So applying that we will get r square as it is Again keep r constant and derivative of x will be 1 minus keep x as it is and derivative of r will be del r by del x. Now apply u dot v rule. So we have to keep x upon r constant and derivative of f dash of r will be f double dash of r into del r by del x. Now replace the value of del r by del x and simplify. Our del r by del x was x upon r. So replace and simplify. So you will get del square u upon del x square as f dash of r into r square minus x square upon r cube plus x square upon r square into f double dash of r. Name this as equation 1. Now similarly we can find del square u upon del y square by just replacing x by y. And lastly we can find del square u upon del z square by just replacing x by z. Name these two equations as 2 and 3. Now what we will do? We will add equation 1, 2 and 3. So on adding we will get del square u upon del x square plus del square u upon del y square plus del square u upon del z square is equal to f dash of r into 3r square minus x square plus y square plus z square upon r cube plus x square plus y square plus z square upon r square into f double dash of r. Now we know that r square is equal to x square plus y square plus z square. So this will become totally 2r square. And here if we put r square, these two will get cancelled out. So finally what will remain? 2 upon r f dash of r plus f double dash of r. So this is our required answer. So now let us see one more example. If r square is equal to x square plus y square, here only two variables are given and u is equal to f of r, then we have to prove that del square u upon del x square plus del square u upon del y square is equal to f double dash of r plus 1 upon r f dash r. Or the question can be asked as, if u is equal to f of r and x is equal to r cos theta and y is equal to r sin theta, from this also we can write it as r square is equal to x square plus y square. Then again we have to do the similar thing. So in this sum only just repeat similar steps done in the above sum by removing the terms containing z and you will get your solution, right? So I hope you understood all the three important sums of chain rule. Thank you for watching.